Okay, so in the last video, um, we computed the maximum loss given default. Now, um, sorry about sighing. We could make when we change something, and what I'm thinking about changing is the loss given default. When we change the loss given default, or when we change the credit spread in particular, even when we change the fees or anything like that, what happens is this implied credit spread should change. If we have a higher credit spread, it should suggest that we could accept a much higher probability of default, and what happens is this difference doesn't become zero. So what we really want to do is change the goal seek every time we do this. Now, we could kind of do the simple method, which was just to make this difference, and maybe this you'll say is just fine. And what we want to do is change this, so this is the probability. How about PD? I think that would be okay. If it was PD1, it wouldn't be okay because that's somewhere a cell somewhere. So we have a range name for the difference and the PD. And this time when we make the goal seek, we'll put data what if analysis, and we'll go to goal seek, and it's slow a little bit, but that's mainly because so set this to 0. It's always the difference to 0. Get used to that by changing this one, and then we'll press OK, and we did, and I didn't make a macro when I did this. What an idiot. So let's make the credit spread go down a little bit, and I copied the spinner button to the loss given default estimate, so we're eventually going to do this goal seek with a macro and attach the macro to these two buttons or all of the buttons. I'm not going to do that because I hate doing that. And then every time you press the button, it'll clunk around and do the goal seek, which may be okay. It's not that bad, really. Okay. So this time again, we have a little bit of a difference. So this time we can make a macro, call it goal seek, and do the same goal seek. Okay, now data what if analysis, goal seek, set the difference to 0 by changing the default probability. Okay, and we got a little bit of a difference. You could change the settings, in Excel to do this. Now, when you do this, there are going to be a couple of things. You better make sure that no, I think it works. Hang on, I was going to say we have to change the sheet name, but we don't. So we go to this goal seek, edit the goal seek, and the range, remember, is difference, and we set it. We change the PD to get there. The reason, at least two reasons you have to do this. If you would like to run this goal seek from this thing, you need the range names, and of course if you insert or delete a line. So we can insert this macro and put the goal seek. And the first thing, and it's not an accident here, but if you have a credit spread that gets into the 5% kind of range, and if it's a long-term loan, these implied probabilities get extraordinarily high. Okay, if you have that kind of credit spread now, you can kind of see what happens if we have a shorter term loan. It's still pretty high, and you can see how sensitive the, whoops, hang on, is this, now it's changing. Oh, I don't know why it didn't change here. Maybe it's the goal seek isn't precise enough, but whatever, you can see how it's working. Okay, now a good idea might be to switch off the video right now, because the next thing I'm going to do is try to, instead of this one being a fixed number, let's make a dynamic goal seek. And when we make a dynamic goal seek, the steps are, and I should put this somewhere, I should really write this down. I hope I wrote it down in the book. But step one is to, we want to set up a starting and an ending value. So what we're going to do is we can start from a default probability of 0 and go up to, I guess, a default probability of 100%. And then as soon as and then each time we do that, we're going to make a function. We're going to need to read in the net cash flow on this without a default, and then we're going to have to understand when all of these mechanics that we did to compute this realized IRR, and then we put our cost of funding in as an assumption. Why is that cost of funding 4.9? I guess that's, we put it as 3.9 or something. What did we do for the cost of funding? The base rate is, this was the cost of funding, okay. And then we'll compute the difference. And if we start with 0, that difference is positive. If we put this as 20%, the difference goes to negative. So we set it up so as soon as you get a negative difference, you stop and redo the simulation. Okay, so let's try that. So you can go to the developer and go to the macros and then go to the functions and press edit. Okay, and I hope you've stopped it by now, by the way, but okay, and that'll allow, because this is going to be tedious and I'm going to make a lot of mistakes. So let's make a function and call it the PD. Now I'm afraid to call it PD because we just named that range. So probability default. Okay, and we have an end function. And we start by reading in what did I say we want to really read in first? Okay. Oh, well, we don't really need anything to read it in first. Remember, I said, well, let's make the start equal 0, the finish equal 100%, 1, and the increment equal 20, something like that, and then iteration, increment, and then our iteration is finish minus start divided by increment. Sometimes I think I do it differently, don't I? Oh shit. Okay, and then so we're going to then make a for loop, and this is the key, for, and we're going to put, this time we can put probably default equal start to finish, and we step by iteration. I think sometimes I step by increment instead of iteration. And then right now, then we'll calculate the difference. That's what we really need to do. Now once we have the difference calculated, then we put if, and let's just pretend from a difference. And that's going to be equal to the IRR realized minus the IRR computed. Now, no, minus the IRR, the cost of funding. Now I have to remember what I just told you, and we said, well, if we put in, if we're starting with 0 here, then we get the difference is positive. As soon as this difference gets to negative, then we have to restart. So we put if difference is less than 0, then we do a lot of things. And the first thing we can do is put another if test. If difference, if the how about absolute value of the difference is less than some really small number, that's kind of like the thing we just saw, then I think we just need to exit the function, because we're computing the probability of default as we go along. Okay, and then we put end if. Now otherwise, we're going to put the, and this is what I kind of do, and I'm kind of having a debate with myself right now whether the start is the iteration minus the increment minus no start is the probability of default minus the iteration, and the finish is the probability of default plus the iteration, and we'll leave the increment as 20. And then here is the big thing, then you have to go around and restart. Okay, and then we're going to compute it again, and so we go to okay, and then now we end if. Okay, now when you have this, I think it's essential to start with a count equal to 1, and then let's just equal because it's very, very easy when you're a bad kind of thinker like me to get into some kind of infinite loop on these. I have just done it so much. So if count is greater than 200, then we'll just exit the sub, exit the function. Okay, and now all we have to do is go back and recompute the difference here. But this illustrates the kind of, let's just review this for just a minute, illustrates what I do. I put a start and a finish, and then when you go down here, we're going to make the start and the finish much smaller, and then we're going to go around and around, and we're going to see when we converge on a really small difference. And when we get there, we're going to exit the function, and if we don't, we better exit it down here. So let's calculate this difference. Now to calculate the difference, let's start at the bottom. So that the IRR cost of funding I'm just going to funding cost. You can see if you spell things wrong, it's going to be a disaster. And that's when you can easily get into an infinite loop. Now, to get the IR realized, we need to go around and compute the net cash flow. And the net cash flow is going to be inside a loop. And this time, I'm going to assume that we just press Shift Control right arrow when we collect our data. So the net cash flow is a function of the probability of default. So we can kind of compute the net cash flow. And I think what we need to do is put the, let's go right up here. We have the, we're going to need these, and let's put the net cash flow without default. I think I've lost most people by now. I assume I have, which is good. Okay, so the net cash flow without default is we get the fees plus all the fees into our pocket. We take away the draws, and we add the debt service. Okay, so that's our net cash flow without default, and we'll read that in for each of the loan periods. Okay, and that's independent. The key thing is that is independent of the probability of default. So let's go and first read in net cash. How about we don't need net cash flow, no default. Now, if you make these numbers way too long, these things, there's a horrible limit on the number of characters you can put into the function itself. So to start with this, let's put period equal cash flow no default. Okay, realize. And then we're going to put for I equal 1 to num periods. And we can adjust this cash flow. We have the how about the what we'll put here is the cash flow with the loss equals the cash, and we're going to need that a dimension on that variable is the cash flow with no default minus the loss. Okay, now, and that's what we've got to, if you do something like this and you forget the array thing, you'll get a big problem. Okay, and we go through the loop, and then we put realized equals the worksheet function dot IRR, and we put the cash flow with the loss. Okay, so that's that, and now we just have to figure out the loss, and you can see the process. The process is that you, for me at least, the process is you try to work backwards, keep the Excel sheet open, and just look at what kind of formulas you had in the Excel sheet. And I suppose one other thing is try to make it as few inputs as you possibly can. So our loss, let's see here, the amount of the loss is the debt service we have. We can do this two ways. Let's see. Just a minute. We can take the debt service and subtract that, and this where it says loss given default, this is really this isn't this. This is a percentage. So we could put the oops, what did I just do? Huh. Excuse me for that. Why don't we put the debt service here? Now, I was debating we could recompute the we could just use the cash flow and just figure out when the debt service starts, but I think it's a little bit lazier, and that means it's better if it's lazier, of course, to read in the debt service, and then the loss is the percent loss times the debt service. Okay, and then, oops, yeah, okay, and then our net realized cash flow is the cash flow without the default minus the loss. Okay. I'm sorry, the net debt service is the debt service times 1 minus the loss percentage. Excuse me for that. And then this is now then the net cash flow is just the cash flow that we started with. Okay, the cash flow we started with minus the loss. We don't need to do it twice, okay? And and maybe as I do this, I'm kind of thinking, well, I should kind of do that always, reprogram it, to make absolutely sure it's really as transparent and as simple as possible. So the first thing we better do is read in the debt service, and that's going to be just like the other one, and our loss is going to be the debt service times 1 minus the loss percent. Okay, so we've got that, but of course I made an error. So I'm saying of course not, because that's of course what you should do, but I'm saying of course I made an error. And we have the loss, and now we have to figure out what this loss percentage is. And the loss percentage equals the probability of default for the period. Because what we're trying to really do is get the starting probability of default. And that we multiply that by 1 minus the loss given default. Okay? And that's a pretty easy one, so we better read in the loss given default. And if we want to make another thing, we can start here. Okay? So far, so good, I think. Okay, and now we have to get the loss, the probability of default probability here, and the default probability is going to be the PD per period. It's going to be the PD per period in the last time times 1 plus the growth, PD growth, which is just an input, and the PD growth is the final input here, hopefully. Okay. What error did I didn't put a comma at the end, obviously, after the LGB. I'm going to make it like this, so we can kind of see it. Okay, so we've got quite a few inputs, but not unbelievably many inputs. Now, the only problem is that this is if I equals 1, then the PD per period equals the probability of default, which is really our starting point. Of course, I should have put in then. And then make absolutely sure that option base 1 is selected. I used to have all sorts of problems, and I forgot to do that. And let's just see, I think we're just about finished, okay? Now, there's no way it's going to work the first time. Absolutely no. If you're like me, maybe you are so much smarter than me that you'll do it. But so let's just see it. If otherwise, we better put. Oops. Okay. Now, does this work? Just a minute. Okay, so this is, we only want to do this here, and remember periodic probability of default is this thing that we took a long time to compute. So now we should be able to enter a function, and it took us, let me see, before we had an error, it took us half an hour, which is what a waste of a half an hour. But then we don't have to attach the goal seeks, we don't have to have the clumsiness of the model. Then the investment certainly might really be worth. Now what I'm going to do is, I don't trust myself, so I'm going to put a, no, well, I'll try it here because it's going to blow up, but we can kind of see the errors. That's good, you can start to see the errors. So we put probability of default down here. That's the function we have now. And then remember, to find these, you press Shift F3. And the first thing is we have to find the funding cost, and we better be really careful. This probably should have said a periodic funding cost, okay? My computer. Now the cash flow with no default, excuse me, is this. And I like to sometimes be able to click on the entire line. Now I've not done it this time. Shift Control right arrow, and you can see that right now we haven't got an answer. There goes the dog. Okay, not so bad, the dog. Okay, and then we put the debt service next. And the LGD is just a single input. Okay. And then the PD growth is the last thing we put in. And we have the annual PD growth. And we press enter. And here is the really bad news, is that when we enter this, and this really kind of stinks, is that we get nothing. And when you get nothing like that, that means that you'll get a value at the end. And you can say, well, did I put in all the I put in all the inputs? No help is available. The formula result is not there. And we press OK. And then the first thing to do is to start looking for, uh-oh, I guess I didn't do that right. PV. Oh. I thought I could do it like this. Obviously, I'm not a very experienced. And cash flow loss, we forgot to put a dimension on that. The good news is, you know, if we could, if it would have told us all the errors, that's really wonderful. And then we have a 4 without a next. Why did I have a 4 without a next? Just a minute. Next probability of default. Okay, and we can put all of these in indent all of them. And we still get a value. And that's the thing that stinks, because we now have to figure out why we get this value. Okay? And that's when I'm going to switch it off and come back and tell you what the problem was. Now, I don't know why it took me so long, and I don't know why I'm so stupid at this stuff, but it was ridiculous. I had to kind of put these things, and the only mistake I made was I Shouldn't have put 1 minus LGD and 1 minus the loss percent, but what the hell. It was really frustrating as hell. It really is. Sometimes I hate this crap. I can't decide whether it's really worth it or not. But let's, so now we have this. Now we take away the credit spread. I mean, the goal seek. Come on, come on, come on. I hope I did. I can't remember where else I put the goal seek. It'll piss me off if I. So if we. Oh, great. It takes a second to do. Now, let me see. Let's put 60%. Come on. This is ridiculous. Oh, come on. Oh, God. No, I'm not going to even worry about why. Oh, I know why. Okay. Okay. Now, okay, I'm just at the end of this video, and I think we'll make the iterations much smaller, and make that this. Let's see if this helps. Okay, that made a pretty dramatic difference, obviously. Okay, and let's see. Okay, I think I'm still okay. Okay, so you can see what this is done. Okay, and you can see that if you have a longer tenor, you can accept an incredibly high probability of loss. If we put a higher commitment fee, we can and I don't know why I put the higher upfront fee in here. Okay. Okay. So that's that. And I'm not going to make a video right now because I'm totally frustrated by this damn thing.